about some triangles. Alright, so today we are going to learn how to solve right triangles using basic trig. And to review, a right triangle is a triangle that has 90 degrees, usually given by this square. And then if you're given an angle, this is the opposite side, the one next to it's the adjacent, and then the hypotenuse. Special right triangles include a 30, 60, 90 triangle, which have sides of 1, root 3, and 2, and a 45, 45, 90 triangle, which have sides 1, 1, and root 2. To solve right triangles, you can use SOHCAHTOA. So means sine equal, the sine of the angle equals the opposite over the hypotenuse. Ka means that the cosine of the angle equals the adjacent over the hypotenuse. And TOA means that the tangent of the angle equals the opposite over the adjacent sides. Alright, so if we were to put this into a practice problem, we are given a side 5, an adjacent angle of 56, and that's it. So we have to solve for the other angle, the hypotenuse, and the opposite side. So to find this angle, you can pretty much just subtract 90 from 56 to get this angle, which will be 34. And to solve for the opposite side, you can use the tangent, TOA over here, of 56 equals b over 5, which can be simplified to b equals 5 times the tangent of 56. And if you plug that into your calculator, you should get about 7.41. And to solve for the hypotenuse, you can use cosine because you have an adjacent side and you're solving for the hypotenuse, given cosine. So you can get that cosine of 56 equals 5 over c, or simplified, it can mean that c equals 5 over the cosine of 56. And if you plug that into your calculator, you should get 8.94 for the hypotenuse, and the triangle is solved. So that's how you solve right triangles using basic trig.
Alright, not every triangle is a 90-degree triangle. So for those other triangles, they're in the format large angle A, large angle C, large angle B, with the corresponding sides little c, little b, and little a. So if we want to solve for one of these sides, while knowing two of the other sides and an angle of either one, we can use the law of cosines. The law of cosines is a set of three equations. Little a equals little b plus little c squared, all of them, minus 2bc cosine of large angle A. And then the other two are for the side B or the side C. So an example of this in action is if we have a triangle like this. We have one side, side B, is 11, side A is 8, and the angle C is 37. We want to solve for little c, or this side down here. Now, we know that the equation little c squared equals a squared minus b squared equals 2ab cosine large c, or large angle. So we can put it c squared equals 64, the square root of 8, plus 121, the square root of 11, equals 176. That's 2bc. And then the cosine of 37, that angle, is 0.798. Now we can simplify that down. We get c squared is equal to 44.44. And then we take the square root of both sides. So we get this side c is equal to 6.67. And that's the law of cosines.
Alright, now we're doing law of sines. This is the law of sines, or the equation for the law of sines, which is sine A over A. The capital letters are the angles, and the lowercase letters are the sides. So you can have sine A over A equals sine B over B equals sine C over C. Or you could flip it to also have A over sine A equals B over sine B equals C over sine C. And the two triangles the law of sines works with are triangles with an angle and two sides, or two angles and one side. Alright, so with one angle, two sides, we bring it over here, and you take the things that are opposite of each other, and we want to solve for this angle, so sine B. Sine B, you take that over the opposite length, which is 16, and put it equal to sine of 115 over 123, and you want to get sine B by itself. So you multiply both sides by 16. You have sine b equals sine 115 times 16 divided by 123. And then you take the inverse sine of both sides, and then b will equal 6.8. And then with ASA, we want to solve for a side, so we can use the bottom equation and have a over sine 116. And then since we have this given as a side, we need to find the angle opposite. And these are also given, so you take 180 minus 116 minus 30 equals 34. You can have a over sine 116 equal 19 over sine 34. And to get a by itself, multiply both sides by sine 116. You have a equals sine 116 times 19 divided by sine 34. If you solve that out, you get a equals 30.5. And that's the law of sine.